Good morning, student. We'll begin the lecture number 6, Unit 1, Moment of Inertia. We'll take two numericals on parallel axis theorem. First problem. Calculate the moment of inertia about the tangent passing through the vertically lowest point of a semicircle and whose diameter is parallel to the tangent. Radius is 75 mm. Here the diagram or the figure is not given. So you have to draw it on your own. Let's see how we will try to solve it. What first is given? Semicircle. How the semicircle is? Radius 75 mm. Then what it said is that the vertically lowest point through which the tangent passes. So the tangent touches the vertically lowest point. That means the vertically lowest point has to be a curve. Therefore, the semicircle part, the below part of the circle, that is the diameter, is parallel to x-axis and the remaining curve will be the below it. Okay? So let's see how the figure appears. This is the figure. We have a semicircle, center of gravity or centroid G, x-axis, that is axis, horizontal axis passing through G. The tangent here is touching the vertically lowest point, that is the arc. So the tangent AB, the radius R is 75 mm. The distance between two parallel axes, that is the axis XX and the tangent AB, is given as H. If we look at the geometry of the figure, the distance O and G is given by 4R divided by 3 pi. I repeat, distance OG is given as 4R divided by 3 pi. This is from the geometry part. Okay. In our previous lecture, we have studied various formulas for determining the center of gravity or the centroid location. Already it has been given to you. So taking that reference, we can determine the later part. So next slide. Given data, R is equal to 75 mm. We have to find moment of inertia about the axis AB, that is IAB. Solution: IAB, by using parallel axis theorem, IAB is equal to moment of inertia about centroidal XX axis plus, in bracket, area of section into square of distance between them. Mathematically, it is expressed as IAB is equal to, in bracket, IG plus AH square, bracket close. Now IG is nothing but moment of inertia about an axis passing through centroid. So here in this diagram, we will consider moment of inertia about axis XX, which is passing through the centroid G. So we get, in bracket, IXX plus AH square. Next slide. Now IXX is equal to 0.11 R raised to 4. Again given, formula given. A, that is area of semicircle, is pi R square by 2 by geometry. H is equal to R minus 4R divided by 3 pi. So if we substitute the value of I-axis, A and H in the formula of parallel axis theorem, we get IAB is equal to 0.11 r raised to 4 plus area pi r square divided by 2 into H. H is given here as r minus in bracket 4r divided by 3 pi whole bracket close square. I hope it is clear. 0.11 r raised to 4 is I-axis. Area A is pi r square divided by 2. H is equal to, H square is equal to r minus in bracket 4r divided by 3 pi whole square. This expression is clear to you. Now we will just substitute the given value in this expression. What are the value given? We know r is given. We know the value of pi. Only two values. Okay. R is given, that is 75, and pi we know 3.14. So we'll just substitute that value. So we get IAB is equal to 0.11 into, in bracket here r is 75, so 75 raised to 4 plus pi into 1 by 2, that is pi divided by 2 into 75 raised to 2. This is for area, pi r square divided by 2. Next, h square. Again, h square, here 75, that is r, minus 4 into 75 divided by 3 pi whole square. This is h square. Here, the value of r is equal to 75 is being substituted. Solving this, we get the answer IAB is equal to 19.946 into 10 raised to 4 mm raised to 4. So, student, this is the answer. I hope this numerical is clear to you. We'll move on to the next numerical in next slide. Question number 2. The given figure of shaded area remaining after equilateral triangle has been removed as shown in figure. Determine the moment of inertia about its base. Now here the figure is already given to you. Let's study the figure first. The figure is, you see a rectangle where B is equal to 100 mm, the depth 160 plus 40, 200 mm, and in this rectangle we have cut out a triangle shape. The triangle shape, it's an equilateral triangle. You can see small b is equal to 50 mm. So in between this is cut out triangle. The base AB. Now we have to find moment of inertia about the base AB. About the base AB for this complete section. Now here the height of the triangle is given by h. Height of the triangle is given by h. We have to find out h. And after finding out h, we have to find out area for rectangle. Then we have to find area for triangle. Then using parallel axis theorem, we have to determine IAB. Let's solve it. Here, again more detail in this diagram. So if you look at it, it is again a rectangle. Again the same diagram. Only thing here is we have mentioned G1, that is the centroid of rectangle area. The centroid of rectangle area. Then we have G2, the centroid of the cutout triangle section. The centroid of cut out triangle section. So we have x1, x1. This is the axis passing through the centroid of rectangle section. Passing through the centroid of rectangular section. Similarly, x2, x2 is the axis passing through the centroid of the cutout triangular section. Centroid of cutout triangle section. Now, the distance G1 from the base is given by H1. If you look at the right hand side, G1, distance between G1 and axis AB is H1 is 100 mm. You see, the complete depth of the rectangular is 200 mm. Half of it, the centroid is located at half of it. So, G1 to the base is D divided by 2. D divided by 2. Here D is 200. 200 divided by 2, 100 mm. Okay. Next, the distance between the distance between axis x2 and AB is given by H2. Now, what's H2 is equal to? H divided by 3 plus 40. H divided by 3 plus 40. 40 mm already given. That is from the base of triangle to the axis AB. From the base of triangle to the axis AB, it is 40 mm already given. Now the distance from the base of triangle to the centroid G2 is H divided by 3. H divided by 3. This is from the geometry part. That is, we have studied in applied mechanics. If we want to have a centroid of a triangle from the base, then it is given by H divided by 3. H divided by 3. So, H2 is equal to H divided by 3 plus 40. H divided by 3 plus 40. So I hope things are pretty clear. We have got B 100 mm, capital B for rectangle. We have capital for D 200 mm for rectangle. Then the side of triangle B is equal to 50 mm. H1 is 100 mm. H2 is H divided by 3 plus 40. Now this is we have solved in our next slide. Let's see. The given data for rectangular B is equal to 100 mm, D is equal to 200 mm. Second, for triangle B is equal to 50 mm. The height of triangle H, by using trigonometry, it is 50 divided by 2 tan 60. We get it 43.3 mm. 43.3 mm. Therefore, A1 is equal to area of rectangle is equal to B into D is equal to 100 into 200. A1 is equal to 2000 mm square. That is 20,000 mm square. 20,000 mm square. A2 is equal to area of triangle. A2 is equal to area of triangle, which is given as half base into height. Half base into height. Here it is half into small b into height h. Therefore, A2 is equal to half, that is 1 by 2, base 50, height 43.3. So A2 is equal to 1 by 2, 50 into 43.3, which is equal to 1082.5 mm square. 1082.5 mm square. Next slide. Now we have to find the moment of inertia of the given section about its base AB. We will be applying parallel axis theorem. Moment of inertia about AB is equal to, we have to find moment of inertia about AB for rectangle section. We have to find moment of inertia about AB for rectangle section, and then we have to subtract, we have to minus the moment of inertia for about AB for the triangle section. ठीक है, ऐसे प्रॉब्लम में सबसे पहले हमने अलग सा मोमेंट ऑफ इनर्शिया रेक्टेंगल सेक्शन के लिए निकालना है। जिस तरह से हमने प्रीवियस प्रॉब्लम में किया था कि एक रेक्टेंगल सेक्शन आपको दिया गया है तो सिंपल फॉर्मूला यूज करके हमने निकाला था, तो वैसे ही यहाँ पे अब दो फिगर है, एक रेक्टेंगल फिगर है और एक ट्रायंगल फिगर है, तो पहले हमें एक फिगर यानी रेक्टेंगल फिगर का मोमेंट ऑफ इनर्शिया अबाउट AB निकालना है, फिर उसमें से हमें मोमेंट ऑफ इनर्शिया ऑफ ट्रायंगल सेक्शन माइनस करना है। मैं रिपीट करता हूं, पहले रेक्टेंगल सेक्शन के लिए मोमेंट ऑफ इनर्शिया निकालना है, उसके बाद ट्रायंगल सेक्शन के लिए मोमेंट ऑफ इनर्शिया निकालना है, और फिर रेक्टेंगल सेक्शन में मोमेंट ऑफ इनर्शिया फॉर रेक्टेंगल सेक्शन में से माइनस ट्रायंगल सेक्शन का मोमेंट ऑफ इनर्शिया माइनस करना है। ठीक है, अब ये मैथमेटिकल एक्सप्रेशन देखिए, I AB is equal to I G1 plus A1 H1 square bracket close minus bracket open I G2 plus A2 H2 square bracket close। So पहला जो है I G1 plus A1 H1 square, ये क्या रिप्रेजेंट करता है? ये रिप्रेजेंट करता है इनर्शिया ऑफ रेक्टेंगल सेक्शन, मोमेंट ऑफ इनर्शिया ऑफ रेक्टेंगल सेक्शन अबाउट एक्सिस AB। दूसरा जो है I G2 plus A2 H2 square, ये क्या रिप्रेजेंट करता है? ये रिप्रेजेंट करता है मोमेंट ऑफ इनर्शिया ऑफ ट्रायंगल सेक्शन about axis AB। Next equation, IAB is equal to IX1 plus A1 H1 whole square bracket close minus bracket open IX2 plus A2 H2 square bracket close। तो ऊपर का इक्वेशन था उसको मॉडिफाई किया, IGI की जगह IX1 रिप्रेजेंट किया और IG2 की जगह IX2 रिप्रेजेंट किया। क्यों? क्योंकि ये दोनों रिप्रेजेंट करते हैं पैरेलल एक्सिस पासिंग थ्रू सेंट्रॉइड। H1 is equal to distance between parallel axis x1 and axis AB is equal to 100 mm। H1 क्या है? डिस्टेंस बिटवीन पैरेलल एक्सिस x1 and axis AB हमने पहले डायग्राम में देखा. We have seen in the diagram that the distance between the parallel axis x1 and axis AB is 100 mm, which is h1. Already we have seen it in the diagram. Next, h2. H2 is equal to distance between parallel axis x2 and axis AB, which is equal to h divided by 3 plus 40. H divided by 3 plus 40. Here h is equal to height of triangle section. Height of triangle section, which is divided by 3 plus 40. I hope this is clear. Now let's solve the numerical. H3 plus 40 is equal to, here we have already find h is 43.3. 43.3 divided by 3 plus 40 is equal to 54.43. Now IAB is given as in bracket I x1 plus a1 h1 square bracket close minus in bracket I x2 plus a2 h2 square bracket close. Here we know I x1 that is moment of inertia for rectangular section about x-axis. Moment of inertia for rectangular section about x-axis is given by BD cube by 12. Is given by BD cube by 12. I x2 is moment of inertia about x-axis for a triangle section. Moment of inertia about x-axis for triangle section, which is given as B h small h cube divided by 12. B small h cube divided by 12. Already this formula we have studied in our previous lecture. So what we get, IAB is equal to bracket open capital B capital D cube divided by 12 plus A1 H1 square bracket close minus bracket open small b, that is the base of triangle, small b, then small h, that is the height of triangle, small b h cube divided by 12 plus a2 h2 square bracket close. Substituting the value, we get IAB is equal to in bracket 100 into 200 cube divided by 12 plus 20,000 into in 100 square, 20,000 into 100 square bracket close. This is for area, moment of inertia for area of rectangle section. Minus in bracket 50 into 43.3 cube divided by 36 plus 1082.5 in bracket 54.43 bracket close square. So here if you again look at the same equation, 100 is capital B, 200 is capital D for a rectangle section, 20,000 is A1, that is area of rectangle section, H1 is 100, so 100 square. So what we get, BD cube divided by 12 plus A1 H1 square for the rectangle section. Minus we have small b h cube by 36. Small b base of triangle 50, small h 43.3 divided by 36, plus A2 is given as 1082.5, H2 is given as 54.43. So, if we solve all the above equation, what we get is answer IAB, that is moment of inertia of the section about axis AB is equal to 263.35 into 10 raised to 6 mm raised to 4 into 10 raised to 6 mm raised to 4. I hope things is pretty clear to you, student. Next problem. Now this problem is for your assignment, for your self-study, for your homework. So you have to solve this numerical. Question number 4. A rectangle hole is made in a triangle section as shown in figure. Determine the moment of inertia of the section about x axis passing through its centroid and the base BC. In exam it has been asked for 8 marks. The diagram is directly given. Let's see. Now this is ABC, the triangle section. ABC, the triangle section, in which a rectangle cutout is there. Rectangle cutout is there. Okay. Now, if you look at the triangle section, its base B is given as 100 mm. Its base B is given as 100 mm. Height 30 plus 30 plus 30, 90 mm. 30 plus 30 plus 30, 90 mm. For rectangle section, if you look at it, it's a cutout. Its base B is given as, its base or width is given as 200 mm. 200 mm. I'm sorry, my mistake. It's given as 20 mm. It's given as 20 mm. And its height or depth D is given as 30 mm. Its depth D is given as 30 mm. So we have triangle section 100 mm and base and height 90 mm, and we have rectangle section with base 20 mm and height or depth 30 mm. So student, please solve this numerical. Thank you.